Let's work through question number 15 from chapter 7. So the question says a population has a mean of 200 and a standard deviation of 50. Suppose a simple random sample of 100 is selected and x bar is used to estimate mu. What they're asking us to find here is what is the probability that the sample mean will be within plus or minus 5 of the population mean. So the first step we should do is write down the pieces that we're given. So we are told that our mu, our population mean, is 200. Our sigma, our population standard deviation, is 50. And our sample size, little n, is 100. Now before we can move on and figure out the probabilities, we need to prove that this is normally distributed. So the proof that we're going to use here is that our sample size, n, is greater than or equal to 30, and sigma is given. Once we have that proof, now we can draw the bell curve. So the first step on the bell curve is to put your mean right in the middle, right? So we draw the line and we put 200. We're trying to figure out the probability that the sample means within plus or minus 5. So we put that on our bell curve as well. Now, we are going to be looking for this area between 195 and 205. That area underneath the curve. To do that, we're eventually going to need to find z-scores. But to find z-scores, we first need to find our standard error. So our standard error is sigma over the square root of little n. Well, we have all of our givens up in the upper left, and we were given sigma and we were given our n. So we can plug those into this formula. So our standard error is 50 over the square root of 100, which comes out to 5. Once we have that standard error, we can now find our z-scores. So we find our z-score for each point on the curve. So 205 minus 200 all over 5, and 195 minus 200 all over 5. And that's going to give us z-scores of plus and minus 1. With those z-scores, we can now look up in our z-score table in that booklet and find the areas. Now the areas are always going to be the area to the left of our z-score, right? So when we look up -1 in our z-score table, we'll find that that area to the left is 0.1587. We do the same for +1, and we see that that area is 0.8413. Well, we're looking for the area between those two. So to find the area between those 2 points, what we're going to need to do is subtract those two areas. So 0.8413 minus 0.1587, that leaves us with 0.6826. So the probability that the sample mean will be within plus or minus 5 of the population mean is 0.6826. So if we look at part B of this problem, what changed here? Well, now it's saying what's the probability that the sample mean will be within plus or minus 10 of the population mean. We still have the same mu, we still have the same sigma, and we still have the same sample size. So we still have the same proof that allows us to say that this is normally distributed. So we draw the bell curve and we put our mean on the bell curve. Now we're looking at plus and minus 10. So now we're going to be looking for the area between 190 and 210. We can now find our standard error. Our sigma and our sample size are still the same. So our standard error is still just going to be 5. Now we can find our z-scores. Our z-scores are going to be slightly different because instead of 195 and 205 that we had back in part A, we have different numbers. So now we do 210 minus 200 all over 5 and 190 minus 200 all over 5. Those are going to give us z-scores of plus and minus 2. So now we can look in our z-score table. We find the area to the left of negative 2, and that's going to be 0.0228. And then we find the area to the left of positive 2, and that's going to be 0.9772. Again, we're looking for the area between these 2 points. So to find that amount, we need to subtract them. So 0.9772 minus 0.0228 leaves us with 0.9544. So the probability that the sample mean will be within plus or minus 10 of the population mean is 0.9544.